Herein we will be taking up a few questions on proportionality theorem as we have discussed it earlier. I just draw the figure and then I write it. It says this is a trapezium. So the names given is A, that's B, this is C, that's D, this is E, and that's more F. I'll just read out this part of the question where it says ABCD is a trapezium. It also informs AB is parallel to DC, and then E and F are points on non-parallel sides which are AD and BC respectively, such that EF is also parallel to AB. We have to prove, so I'm just writing the question part, whatever is given I've read that out. We have to prove AE by ED is equal to BF by FC. To do so, let us join. The construction part is AC is supposed to be joined. Doesn't look that good. I'll just try it again. I have joined AC, which is intersecting EF at this point, which we name as G. Okay, it was given AB parallel to DC. It was also given EF parallel to AB, so thereby making this EF parallel to DC. So we derive EF is parallel to DC. Now EF is parallel to DC, so in this triangle EG also is parallel to DC. Thereby, if I apply the Pythagoras proportionality theorem, excuse me, in this triangle ADC, so we get in this triangle ADC, AE by ED will be equal to AG by GC. Now if I apply this same ECAB, that also has become a triangle wherein this GF is parallel to AB. So we get in this triangle CAB, we will be getting CF by FB, CF by FB equals CG by GA or GA. We actually can reciprocate this, and that would become BF by CF equals to CG by AG or AG. We got AE by ED equals to AG by CG. Oh, I should have reciprocated it. I wanted to reciprocate. Once I reciprocate, I'll be getting AG by GC or CG. GC. Now we got AG by GC even in the first equation. If I name this as 1 and this 2, so the right hand sides are both case equal, so I'm getting AE by ED equals to BF by CF, or that can be written as FC. So from equation 1 and 2 we get AE by ED equals BF by FC. It was not that difficult though. Move on to another question. there is this figure again. This is C, that's that's A, that's B, D, E. In this figure, it says AD by DC is equal to BE by EC. It is given AD by DC equals BE by EC. If you see, this is kind of a proportionality derivation. It also says CDE angle, that is CDE angle, this is equal to CED angle. Oh, these two are equal. Okay, we have to prove CAB to be isosceles. We have to prove triangle CAB is isosceles. To do so, let us understand what we need to prove this to be isosceles. If we can prove these two angles equal, so we can take AC equals BC. Now, because AD by DC equals BE by EC given, by converse of proportionality theorem, we can say that DE is parallel to AB. DE is parallel to AB. If DE is parallel to AB, angle CDE will be equal to angle CAB because they are corresponding angles. On the other hand, CED will be equal to CBA. They are again corresponding angles. But also this part is given that CDE is equal to CDE. That means these two are equal. If these two are equal, thereby making angle CAB equal to angle CBA. These are the two blue marked angles. So the sides opposite to these angles become BC equals AB, thereby making ACB an isosceles triangle. That was even very simple. We take up another question again on this. I draw the figure first. This was A, B, and this is C. This point is O, and the outside part becomes P, Q, and that's R. It says in this figure A, B, and C are the points on OP, OQ, and OR respectively, such that AB is parallel to PQ and BC is parallel to QR. We have to show that AC is parallel to PR. Look at the triangle OPQ, this one. In triangle OPQ, it was said AB is parallel to PQ. So we apply proportionality theorem, thereby getting OA by AP, OA by AP is equal to OB by BQ. On the other hand, look at the triangle OQR. It was said BC is parallel to QR. Therefore, in triangle OQR, OB by BQ is equal to OC by CR, right? This is suppose our first equation and this is the second one. Now look at these two, OB by BQ here in OB by BQ, thereby making OA by AP. From equation 1 and 2 we can say that OA by AP is equal to OC by CR. OA by AP equals OC by CR. That is a part of the triangle OPR, where we got the converse of the proportionality theorem proof, thereby making AC parallel to PR. So this you need to write using the converse of basic proportionality theorem. We get this. Now herein I will be giving a question for you to solve. This is a figure . Let's name it. This is P, this is Q, this is R, this point of intersection is E, this is E, A, this is D, this is given as F. Now the question reads that it's given DE is parallel to DE is given parallel to AQ and DF is parallel to AR. You have to prove EF parallel to QR, this one and this one. It's almost like the previous question. So start doing it and you will reach the proportionality which is derived from EF equal parallel to QR. So then you can apply the converse of basic proportionality theorem to prove this. Hope you do it correctly. Thank you.